When two or more buildings or structures are supplied from a common service, the grounding electrode system must be interconnected and the grounding electrode conductor must be run to each building or structure. In this scenario, the outside load center and the inside load center are considered two separate buildings or structures. Therefore, the grounding electrodes at the outside load center must be interconnected, and the grounding electrode conductor must be run to the inside load center. The grounding electrode conductor shall be sized in accordance with Table 250.66 and connected to the grounding electrode system at both the outside and inside load centers. Firstly, interconnect grounding electrodes. Connect the 3 ground rods and the cold water system at the outside load center using number 4 solid bare copper grounding electrode conductors. Secondly, run grounding electrode conductor. Run a number 4 solid bare copper grounding electrode conductor from the interconnected grounding electrodes at the outside load center to the inside load center. Thirdly, connect grounding electrode conductor. Connect the grounding electrode conductor to the grounding electrode system at the inside load center. Fourthly, bond the neutral bar. Bond the neutral bar in the inside load center to the grounding electrode conductor using a bonding jumper. The grounding electrode conductor used to interconnect the grounding electrodes and the grounding electrode conductor used to run to the inside load center can be run in the same raceway or enclosure. The bonding jumper connecting the neutral bar to the grounding electrode conductor shall be sized in accordance with Table 250.122. The National Electrical Code, or NEC, provides specific guidelines for grounding and bonding electrical systems to ensure safety and proper operation. Article 250 within the NEC is dedicated to grounding and bonding requirements. Understanding and adhering to these requirements is crucial for any electrical installation. Grounding refers to connecting electrical circuit or equipment to the earth. This connection provides a lower impedance path for fault currents, helping to protect people and equipment from electrical shock and damage. Bonding, on the other hand, involves connecting different metallic parts of an electrical system together to create an electrically conductive path. This path ensures that all bonded parts are at the same electrical potential, minimizing the risk of shock. Now, let's delve into the specifics of grounding and bonding a subpanel within a dwelling unit, focusing on a 120/240 volt system. A subpanel, also known as a distribution panel, is a secondary electrical panel that receives power from the main service panel and distributes it to various circuits within a building. When installing a subpanel, it's essential to follow the NEC guidelines to ensure proper grounding and bonding. The NEC addresses the situation where 2 or more buildings or structures are supplied from a common service in Article 250.32. This article is relevant when dealing with a subpanel in a detached garage, shed, or other structure that receives power from the main dwelling unit. In such cases, the NEC considers the main dwelling and the detached structure as separate buildings or structures. Therefore, the grounding electrode system at each building must be interconnected. This interconnection is achieved by running a grounding electrode conductor from the main service panel to the subpanel. The grounding electrode conductor must be sized according to NEC Table 250.66, which specifies the minimum size of the conductor based on the size of the service entrance conductors. The grounding electrode conductor should be connected to the grounding electrode system at both the main service panel and the subpanel. The grounding electrode system typically consists of 1 or more grounding electrodes, such as ground rods, metal water pipes, or concrete encased electrodes. At the subpanel, the grounding electrode conductor should be connected to a grounding bar or terminal. This grounding bar should be securely bonded to the metal enclosure of the subpanel. In addition to the grounding electrode conductor, a bonding jumper must be installed between the neutral bar and the grounding bar in the subpanel. This bonding jumper ensures that the neutral and grounding systems are properly connected. The size of the bonding jumper should be determined according to NEC Table 250.102. It's important to note that the neutral bar and the subpanel should not be bonded to the subpanel enclosure. This practice is different from the main service panel, where the neutral bar is typically bonded to the enclosure. Bonding the neutral bar to the enclosure in the subpanel can create parallel paths for neutral current, which can lead to unwanted voltage drops and potential safety hazards. The NEC also addresses the use of metal raceways and enclosures in grounding and bonding. If metal raceways or enclosures are used to house the electrical conductors, they must be properly bonded to ensure a continuous electrical path. This bonding can be achieved by using bonding bushings, bonding jumpers, or other approved methods. It's crucial to inspect all bonding connections to ensure they are tight and secure. Loose or corroded connections can impede the flow of fault current and compromise the effectiveness of the grounding and bonding system. In summary, the grounding and bonding of a subpanel within a dwelling unit involves several key steps. Firstly, interconnect the grounding electrode systems at the main service panel in the subpanel by running a grounding electrode conductor. Secondly, connect the grounding electrode conductor to the grounding electrode system at both locations. Thirdly, install a bonding jumper between the neutral bar and the grounding bar in the subpanel. Fourthly, ensure that the neutral bar is not bonded to the subpanel enclosure. Fifthly, properly bond all metal raceways and enclosures. By following these steps and adhering to the NEC guidelines, you can ensure a safe and reliable electrical system. It is always recommended to consult with a qualified electrician to perform electrical work and ensure compliance with all applicable codes and regulations. Improper grounding and bonding can have serious consequences, including electrical shock, fire hazards, and equipment damage. Therefore, it's essential to take the necessary precautions and seek professional assistance when needed. When dealing with electrical systems, safety should always be the top priority. Before working on any electrical circuit or equipment, always disconnect the power supply at the main service panel. Use appropriate personal protective equipment, such as insulated gloves and safety glasses. And never work on electrical systems when you are tired or distracted. Additionally, regularly inspect your electrical system for any signs of damage or deterioration. Look for frayed wires, loose connections, and corroded components. If you notice any problems, have them repaired promptly by a qualified electrician. Proper grounding and bonding are essential for the safe and reliable operation of any electrical system. By understanding the NEC guidelines and following best practices, you can protect yourself, your family, and your property from the hazards of electricity. Remember to always consult with a qualified electrician for any electrical work and to stay informed about the latest codes and regulations. Now, let's delve deeper into the specific requirements for grounding electrode conductors and bonding jumpers. The size of the grounding electrode conductor is determined by NEC Table 250.66. This table provides the minimum size of the grounding electrode conductor based on the size of the service entrance conductors. The service entrance conductors are the conductors that bring power from the utility company to the main service panel. To use Table 250.66, you must first determine the size of the service entrance conductors. This information can typically be found on the main service panel label or in the electrical plans for the building. Once you know the size of the service entrance conductors, you can consult Table 250.66 to find the corresponding minimum size of the grounding electrode conductor. For example, if the service entrance conductors are number 2/0 copper, then the minimum size of the grounding electrode conductor would be number 4 copper. The grounding electrode conductor can be made of copper, aluminum, or copper-clad aluminum. However, it must be installed in a manner that protects it from physical damage. This can be achieved by running the conductor through a conduit or other protective raceway. The bonding jumper is used to connect the neutral bar to the grounding bar in the subpanel. The size of the bonding jumper is determined by NEC Table 250.102. This table provides the minimum size of the bonding jumper based on the size of the ungrounded conductors that supply the subpanel. The ungrounded conductors are the conductors that carry the current from the main service panel to the subpanel. These conductors are typically referred to as the hot wires. To use Table 250.102, you must first determine the size of the ungrounded conductors that supply the subpanel. This information can typically be found on the circuit breaker that feeds the subpanel. Once you know the size of the ungrounded conductors, you can consult Table 250.102 to find the corresponding minimum size of the bonding jumper. For example, if the ungrounded conductors are number 4 copper, then the minimum size of the bonding jumper would be number 8 copper. The bonding jumper can be made of copper or aluminum. However, it must be installed in a manner that provides a low impedance path for fault current. This can be achieved by using a short, direct connection between the neutral bar and the grounding bar. The bonding jumper should be securely fastened to both the neutral bar and the grounding bar. Loose or corroded connections can impede the flow of fault current and compromise the effectiveness of the bonding system. In addition to the grounding electrode conductor and the bonding jumper, there are other important considerations for grounding and bonding a subpanel. Firstly, the subpanel enclosure must be properly grounded. This can be achieved by connecting a grounding conductor from the subpanel enclosure to the grounding bar. The grounding conductor should be sized according to NEC Table 250.122. Secondly, all metal raceways and enclosures that contain electrical conductors must be properly bonded. This can be achieved by using bonding bushings, bonding jumpers, or other approved methods. Thirdly, any non-current carrying metal parts of electrical equipment must be properly grounded. This can be achieved by connecting a grounding conductor from the metal part to the grounding bar. By following these guidelines and adhering to the NEC requirements, you can ensure that your subpanel is properly grounded and bonded. This will help to protect people and equipment from electrical shock and damage. Remember to always consult with a qualified electrician for any electrical work and to stay informed about the latest codes and regulations. Improper grounding and bonding can have serious consequences, so it's essential to take the necessary precautions and seek professional assistance when needed.